Alrighty, right. So last week we spent a tremendous amount of our time talking about animation, right? You guys remember that? Talked a lot about animation, a lot about GUIs and UIs, and how all of these things kind of clip and integrate together. Today I wanted to change gears a little bit and start talking about how we can add maybe like a simple weapon system and an introduction to the rigid body dynamic system inside of Modo. A lot of the challenges that you're building and prototyping in your game can be paired directly with a rigid body system to kind of add a cool layer of interactivity. Today we're just going to kind of introduce the ideas. Through this process we'll learn about instantiation. We learned a little bit about how to destroy things a couple weeks ago, especially when we were considering that Boolean switch. Remember that example that we did where every time I touched a red cube it destroyed itself and gave us a point in the game? Remember that? So we've talked already about how to destroy things. I wanted to spend some time on how to create things. A great example of this are coins. Think about it in a game. In a game, you collect all the coins, but what happens when you die? Sometimes those coins are reset. The enemies are reset, okay? We have to be able to take things away from our hierarchy, but we also have to put them back in, okay? This process of creating game objects in our scene is called instantiation, and I wanted to look at that very directly today. In particular, we're also going to kind of piggyback on that idea by talking about how we can create like a very cool, simple weapon system where we instantiate a whole bunch of bullets that are being fired from our game and use those to interact with other game objects inside of our scene, okay? So it's going to be a lot of fun today. Today we're actually going to kind of destroy some stuff and shoot some targets and stuff. It's going to be pretty neat. You ready for it? It's pretty cool? Okay, let's get into it. So I've just kind of opened up a blank scene here, and what we're going to do is that we're going to use just basically all the default game objects inside of Unity to create a very, very simple system, okay? Whenever you're learning something, especially, game development concepts that include some programming, I can't recommend enough extracting or at the very least prototyping these ideas in a very, very simple scene, okay? Simple cubes and planes and cylinders, believe it or not, go a long, long way to helping you understand how all of these things structurally kind of go together, okay? All right, so let's do this. I'm going to do a new scene file here, and I'm going to save my scene as, I don't know, what are we going to call this? We'll just call this rigid, body example, okay? All right, and what I'm going to do here is also just add in a very simple three-dimensional plane. Awesome. Let's make it a little bit bigger. Coolio. Me likey very much. And let's throw in our tried and true rigid body first-person controller. Let's play the game real fast just to see what we get. Make sure everything is at the very least working, and it is. I can jump, cool. I'll stop the game. And since I'm using the rigid body first-person controller, my main camera is giving me a whole series of audio listener errors inside of my console, so I'm going to delete my main camera to resolve those errors. This is what I'm talking about. All this jazz is coming from that default main camera. Let's clear it, get it out of the way. All right. So my rigid body first-person controller is just generally sitting at the origin of my scene, which is what I'm after. And to start off today, let's talk about instantiation, how to create stuff, right? How to physically generate some content or the placement of content inside of our scene. Now, in order for us to do this correctly, we have to generate initially a whole series of prefabs, okay? Now, we've talked a little bit about prefabs in the past. What are they? What are prefabs? Many apologies, Mike. Didn't mean to step on your back. Objects, okay. They absolutely are game objects. Take that one step further. What is a prefab? Bum, 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 bum. Well, that's a good test question, isn't it? Every once in a while I get this sadistic idea of making you guys take an exam. I should do it just one time just to see you guys panic, right? I like it. So it's a pre-constructed object, yeah. And it can be really the combination of many different game components attached and combined into one game object, right? So a prefab is more than just a mesh. a recyclable mesh object that we can place inside of our level. It contains any component piece that's associated with it. And it can even be large groups of mesh objects and components all structured together, right? It really becomes a package of game objects and components. Now for us, what we're going to do, in order for us to instantiate something, we have to have a prefab. Now this is only ever going to work with a prefab. Ultimately, a prefab is going to be placed inside of our assets directory, inside of our Unity project tab. So kind of big picture idea, ultimately we can instantiate anything that's currently in our project tab, but we have to have it there before this whole thing will even ever work. So I'm going to use just some simple examples today to get us up and running. Let's do this. I think I'm going to start off with some capsules. We don't give capsules enough love in this class, so we'll get this going here a little bit. Okay. Now I'm not so concerned about the initial placement of this, but I am going to go in and just see how big it is inside of my game view. I'm just going to place this in front of my first-person controller prefab camera so I can just get a good understanding of its relative size and height. Okay, and that's pretty good. I think that's a pretty good size. Now, what's going to make this a little bit different is that we're going to put a cool material on it. From our previous examples, I have this red material already chilling inside of my project tab, so I'm going to recycle that and place that on my capsule. Awesome. That's good enough for me. I'm really kind of happy with that. You know, one of the things that we could do, well, let's take this a little one step further. Okay. What if I wanted to have my little capsule thing here rotating? Because it's more than just a game object and a material. A prefab can also contain a whole series of scripts. Anything that's attached to the game object will be preserved inside of that prefab. So let's do this. Let's see if we can figure this out real fast. And this is kind of a fun little chunk of code. I want this thing to rotate. How could I do that? I want to just kind of rotate along its own local z-axis. Say again? So we could absolutely make an animation clip, for sure. We've gone over that in the past. But we also can create simple movements. And I mean simple movements through code. Okay? Now, if you think about it, what we're ultimately trying to define here and control is the capsules transformation node. I want to be able to go in and rotate it. We can do it X. I'm not going to do X. I want to do Z. I want to have it rotate like this. Okay? That's my goal. So with that in mind, what I'm really after is a little script here that accesses the transformation channels, or the transformation component, and specifically the rotation Z transformation components. Okay? Now this isn't difficult. We've actually already kind of done this in a couple other places before. But let's go in and start creating a simple little script here that will allow us to do this. Okay? Is that a script here? New script. And let's do, I'm just going to call this red Capsule Controller. There we go. And I'll double click on it. Oops, there we go. Fire it open, good old mono develop. And we'll start going in and looking at how we can animate this thing over time. Come on, mono develop. It's going. All right. So here it is, red Capsule Controller. There's a couple things in here that we want to initially change here. Let's test our system here and see if we can access the correct component, right? And remember how we can go in and access that component? Say again? We could go in and access the debug log, but I want to go in and ultimately control this transform component right here. So remember how to do that. Transform, what was it? Rotation, you got it. So transform dot rotation. Okay. Let's go back over here, and let's do this. Let's see if we can rotate this thing 45 degrees at the start of the game, right? So right now the capsule is perfectly up and down. Let's see if we can rotate along its z-axis 45. Okay. Help me out here. How am I going to do this? Oops, wrong button. There it is. Discovered that the other day. I can interactively change the. It's a simple thing. The size of my font. Okay. So ultimately, what we want to do in here is that we need to go in, access the transform channel, and then the rotation of it. Right. Now it's really kind of easy to do this. So upon function start, we'll do transform. So we're speaking to the transform component now. Transform, oops, I can't type today, dot rotation, or rotate, excuse me. It's not rotation. Transform dot rotate. Okay, and now we've got to tell it how much to rotate it. Okay, so a pair of parentheses, and while we're here at the end, we'll add in a semicolon as well. So we're accessing the rotation channel on the transform component of the game object that this script is attached to. Now, of course, naturally in here, we need to go in and change some stuff, right? X, Y, and Z. What do we want our rotation to be from our previous prototype? 45. Let's just put 45 in there on the Z channel. So when we're going in and changing the rotation of this, we have to physically go in and tell the computer specifically which channels and which portions of that channel we want to change. So let's save the script. Go back over into Unity. We're not getting any compiler errors, which is good. And if we play the game, whoop, it rotates 45 degrees. So we know that we're getting access to the correct channel. The code we're working with here is absolutely working. However, I want it to go and rotate kind of, just infinitely, right? Just rotate very slowly. This is where the fun part comes in. I love this. This is really a lot of fun. Let's go back over into Mono Develop just for 1 second. And now we're going to access a really fun thing. And it's time.delta time, which is how we can access the internal game clock of the Unity game engine and use that number to change the value for us. Okay, so let's just do it real fast. It's really actually quite easy. However, what we need to do is remove the 45, okay? And let's just do time, oops, gotta capitalize it, time dot delta time, like that. Time dot delta time. So now we're accessing the internal clock. So whatever the internal clock's value is going to drive the rotation value of our little capsule. Let's see if it works. Let's save it. Now, unfortunately, are we going to see any change when we play our game? Why not? It's what? It's not doing anything, and you're absolutely right, because when does the function start get evaluated? At the beginning of the game. At the beginning of the game, what's time.delta times equal value? One frame. So basically, we're not doing a single thing here. So here's what we're going to do. We're going to extract this entire line of code and place it inside of the function update, which we know from our previous experience with writing scripts that this is going to the update function is going to be called every frame of the game. So every frame of the game, we're going to be rotating our object along the z-axis according to the time, the internal time clock of the game itself. Let's see what that looks like. Not a single thing, so I've messed up somewhere. Function update. Here, let's just put this back to 45. I'm going to cut it. Put it back to 45. Just make sure. Let's see what it's doing now. There we go. It does 45 every frame, so we want to slow that down a little bit, right? I messed up. This is my my problem, and I apologize for this. I got a little ahead of myself. Because, huh? Yeah, and because what we could do in here is that we could, if we wanted to, let's do this. Let's wrap the 45 in a pair of parentheses, and then we can multiply it, which is shift 8, by time.delta time. We'll save that.
The time.delta time is working, it's just moving extremely slow.
Now it's moving very, very slow. Yep. Which is cool. Oh, was it moving slowly before? Yeah. I was impatient. Yeah. I assumed that I was in error. Yeah. When I put that in, I was like, I'm pretty sure this is supposed to be working. Why isn't it working? So this is working. Yay, right? However, maybe it would be cool to give the game designer or maybe the person that's building this level a little bit more control over how fast or slow this little capsule rotates. Okay? So let's do this. This is a great way of exposing certain chunks of information in the inspector so that we can control it in Unity, control the speed of rotation in Unity, instead of having to go in and do it through our code in MonoDevelop. So let's do this. I'm going to make a variable called speed. And let's declare that variable speed. What type of number is this? Let's make it an integer. Okay. A whole number. Let's save it. Go back over into MonoDevelop, and if we look at our capsule now, check it out. That speed value is now exposed in the editor itself, in the inspector panel, which allows me as the game designer to go in and kind of choose how fast or slow I want this object to be cruising around. So I think we were using 45 last time. Let's put 60 in there and see what we get. Yeah, a little bit faster, which is pretty cool. If I stop the game and change my speed value once again, let's put it to 120. So now it should be twice as fast as where it was before. Yep, now very noticeably faster. It's a great way, having these public variables in our scripts attached to a number is a great way to expose that little chunk of data in the inspector here in Unity. I don't have to go back and monkey with the code now. Now I'm just changing the variable's value in the inspector, which is pretty neat. Okay, let's stop the game for a second. And let's rename this thing. What's this thing going to be called? This is going to be our target. Okay. Now, this target, if you remember, of course, is a basic, excuse me, this is just a basic capsule, capsule collider, but I've given it its own custom material. It's called red. And then it also has its own custom script that's controlling the rotation of my object across infinitely. And on simple movements like this, it's good to do it with code versus having to make an animation clip. Can anyone imagine why? We can reuse it a lot, right? Animation clips get quite big. Really what it's doing is that it's saving vertex information, vertex position information inside the animation clip, right? At times, these can get quite heavy, quite big. The file sizes can be large. And if you have a lot of them, now we're not making probably the most optimized game environment. For simple things like this, do it with code, right? It maintains, it's almost, it's like 1 byte bigger now, okay? The file size is not astronomical, and the number of individual chunks of information that the rendering engine is having to manage now is getting reduced. There we go. Cool. All right. So now it's time to transform my little target here into a prefab. Does anyone remember from our previous kind of understanding of this process how we generate a prefab? How do we create one? Because my target game object has a number of custom game components associated with it. I wanted to save that and reuse them. Maybe obviously I want to have a whole bunch of targets all across my map. Yeah. You got to drag it down to the project tab, right? And then it instantly turns into a prefab. I'm going to drag down into my project tab. Bloop, there it is. Notice that it gets its own little blue cube document icon, which is pretty great. If we select it and look at it over here in the inspector, we can still see all the component pieces that are using to create this thing. If you look up here in your hierarchy, since it's now a prefab, the label for this game object has gone blue. What is that? Why is it blue while the plane is white? What does that blue label color represent? Close. The blue label color for that object says that it's a prefab. Okay? So that color blue becomes a much more important role. Makes sense, too, because if you take a step back and look at it, the rigid body first-person controller was also a prefab, right? So any blue object is going to be a prefab. Okay. So now check it out. I'm actually going to get rid of this one inside of my scene. Right-click, choose Delete. And check it out. Now I can grab from my Project tab and place this thing however many times I want inside the scene itself. I can place one there. I can place one there. It doesn't matter. I can have as many of these inside of my scene as I like. When I play my game, they should all be sitting there spinning. Ah, awesome, right? Excellent. Very cool. Power of prefabs. We've created a true recyclable element that we can use over and over and over and over again. Now, from time to time, we're not going to want to hand place these objects inside of the scene itself, right? We're going to want to instantiate them. Consider for a second, you're playing like Mario Brothers, okay? You're running through the level, everything is going good, life is awesome, but then you die, right? And then maybe that upon that death, you realize, oh, that was my last life. I got to restart the entire level all over again. What happens when you restart the level? Everything's back, right? All the coins are back in their original places. All the enemies that you just previously killed have returned to their initial starting points, right? Those initial starting points aren't determined by placement, by hand placement, as I've just done here, right? I've taken each one of these prefabs and I placed it in very specific areas. It's not determined by hand placement. It's determined by instantiation, which is a programmatic way of creating things at very specific locations inside of our three-dimensional scene. Okay? Since we're programmatically placing them, we can replace them over and over and over again, right? Upon a condition. So let's just take a look at this. Now, the process of instantiation is really easy. But there's a couple things in here that we need to look at. Okay? And I'm going to get rid of these 3 targets. Okay, awesome. All right. So the process of instantiation is really quite easy. But there's a couple things in here that we need to do first. Okay? First, I think what I'm going to do is create an empty game object. And this is going to be kind of like our global game controller. Okay? Now the role of this come on, fingers. I cannot type today. Global game controller. The purpose of this empty game object is really just to house scripting information. Because I need to have some game object inside of my scene that's responsible for, like, creating and destroying, something that's kind of controlling the level. In a previous example, we had a global variables list. Do you remember that? Yeah, this is kind of a very similar, game objects inside of our scene, okay? In my mind, this is like the puppet master behind the scene, this game object, okay? That's controlling when things are created and when things are being destroyed and how the conditions are being met and all that jazz, okay? So I'm going to add a script here. New script, and let's just call this game. We'll recycle the title, Global Game Controller. We'll open it up in MonoDevelop and take a look at what we got going on. Okay. Now, in MonoDevelop, or in the script, we have to do a couple things when we call the instantiation command. Let's take a look at it. Because, as I've said before, when it comes to programming, it's not about knowing every single command. It's not about knowing every single variable or argument or whatever. It's about knowing where to find that information, right? For me, I know pretty quickly, or I remembered from my experience here, the command that we're going to use is instantiate, Instantiate. Okay? Make sure I'm spelling that right. Yep. Does anyone remember the keyboard shortcut that allows us to search that word against the Unity documentation? It's a good one to commit to memory because you're going to be doing this all the time. What is it? Does anyone remember? Close. It's command quotes. The one to the left of the return key. Command quotes. Yeah, or command apostrophe, depending on the way you want to look. And as you can see, check it out. It searched the entire Unity documentation website for the word instantiate. And it's given us a whole bunch of results. Check it out. And specifically where we're going here is object instantiate. Now right now we're using the C# coding language. Let's go over to JavaScript just for what we're doing. And you can see pretty quickly here exactly what it needs, right? We can instantiate an object, but we also need to hand in some little chunks of information. I always like to find little code snippets down here. Yeah, and this is specifically what we're after. So here it is, instantiate. Now what we need to do here is that we need to tell it what to instantiate. Makes sense, right? What to create, okay? And then where it says new vector 3, that's where to instantiate, okay? So we do what, where, that's the new vector 3, and then we have 3 values for an x, y, and z location, right? And then what's that quaternion identity? You're going to love to hate this. That's rotation, okay? So if you take a step back and look at what we're asking the computer to do, we're telling it to create something inside the scene, but then we're telling it where to create it and what rotation angles need to be applied to that instantiated object, okay? So what, where, and what rotation. So what, position of object, rotation of object, okay? All right. I definitely encourage you to check this out. All right. So we're going to do this thing once. Let's just do this, okay? We don't want to do an update. I don't know why I put it in update. Let's go in. Instantiate. Okay, now remember, we have to do some sort of prefab. Got to be a prefab. Then we need position information, and then rotation information. That's what this command is looking for. A what, a where, and what angle. Now the what is pretty easy, right? The what is going to be the prefab, the target prefab that we just created. But how we're going to call this is a little bit differently. I could certainly go in and give it and hard code in a name, but kind of drawing from something that we just talked about with the speed variable of our rotation of our capsule, maybe we can generically write it with a variable. So let's do this. The what is going to be a variable, and let's just give it a name. Let's just call this Pat's target. So we'll do variable. Oops. Pat's target. Now what this is going to be, if we put transform in here, we can load in a game object in there. Okay, which is pretty great. We could also put game object if we like, but transform is going to work for what we're going to do. Now, the location of this is where it gets kind of fun, right? Because we can either hard code in a value, or we can do it generically. Let's do the hard code value first, and then maybe we can look at a way that we can make it a little bit more generic, so we can interactively instantiate these objects where we want them to be instantiated, okay? All right. So let's do this. Let's do new vector 3. X, Y, and Z. Okay, so let's choose to place this object. Let's do it real simple at first. We'll instantiate it right at the origin of the scene, which is 0, 0, 0. But the only thing that I'm going to do differently is I'm going to raise it above the ground a little bit so it's not in my ground plane. Let's put this at a value of 3. Okay, awesome. If we go back into the Unity documentation, this does a really great job of telling us how to do the rotation. Now, rotation can be a little bit interesting because we have to define pretty quickly what model of rotation to use. Quaternion.identity is a great model, and I'm going to save you from the 3-hour conversations on the rotation models because there's actually a couple of them. One's called quaternion, the other one's called Euler. It's the foundation of understanding kind of a local versus global understanding of that location, that game object's rotation. So I'm just going to do quaternion.identity. Let's go back over in here, and I'll paste it in. Okay. There we go. We'll save it. Go back over here into Unity and see what we get. Hopefully we don't have any compiler errors, and we don't, which is pretty great. The last thing that we need to do here is tell the computer which prefab to instantiate. And this is the cool thing about making it a public variable. Instead of hard coding it in, I now can put anything in there. I can just grab my target, put it in that transform section, and let's see if it works. Bloop. There it is. It created that object very specifically for me. Okay? And what's my little capsule doing? It's moving, right? So it's still the red color. It's still moving the way it's supposed to move. We like you very much. Okay? I like this. Okay. Now we're talking. Now we can physically go in and generate something. Okay? Now at the moment, oops, excuse me, wrong app. At the moment, we are hard coding in the location of this instantiated capsule with that little chunk of code there. We're very directly saying your new transform location is these 3 values. Okay? 0 on the X, 3 on the Y, 0 on the Z. Is there a way that we could go in and maybe generically write this? Go back to your spawn point experience in here. I like it. Okay. But what transform position? Let's do this. Let me help you out. Here's what we're going to do. I want to take the position of maybe another game object to feed those values, right? That's easy, because then I can have an interactive, basically, locator that I can drag around inside of my scene and pick and choose where I want this thing to go. Now, this is only going to work for a single spawn point, but let's do it all the way. We'll do spawn point dot transform. I cannot type today. There we go. Spawn point dot transform. So this is a variable. We're going to do the exact same thing that we did here, but again, this new one's going to be spawn. Oops. Make sure it's spelled the same way. Come on, fingers. Spawn point. Okay. So now what we're going to take is we're going to take the spawn point's position, okay, to determine where my little capsule is going to be generated. So now what we have to do, go back over here in Unity, and it's saying, hey, I don't understand what this is. Spawn point dot transform. Okay, mostly, we'll leave this quaternion.identity in there for the time being. Let's make sure. Yep. Let's do this. Now let's add an empty game object. I'm going to call this, I don't know, capsule spawn point. Okay. And I'm going to place that game object wherever I want inside the scene. Maybe over here. Okay. If we go back into our, oops. What's going on? No, like something. Instantiate. Here, let's do this. We'll do rotation. Oh, you know what? I didn't have to do that. I'm a dork. This is spawn point dot position now. And spawn point dot rotation, that works just the same. Now it should go away. Bloop. Wonderful. And that variable has now been exposed inside of my script. Let's load it in. Capsule spawn point is going to get loaded in there. If we grab capsule spawn point, it's way off over here in the distance. It's no longer at the origin of my scene like it was before. Let's play the game, see what we get. Bloop. My capsule spawns way over there. The cool thing about this process is that this is now interactive. I can just move that one locator and determine where I want my capsule to be generated. Cool, huh? Pretty neat. Yeah, pretty neat. Further examples and understanding of this is to create a whole series of these spawn points, and then ask the computer to randomly pick one. Yeah, which is pretty neat. You can do that with an array, which is pretty neatio, to randomize it. Yes, sir? This is where it gets to be a little bit of a challenge, right? Because if you want a whole bunch of these things to be spawned at the exact same time, how are you going to do that? You need to define a whole series of locations, but each instantiated copy needs to be pointed to a very specific location inside of the scene itself. Say again? Yeah, potentially that would help, for sure. And you have to instantiate this a number of times. How many times are we instantiating this right now? Let's just go and do it real fast. Yeah, we just got to create separate spawn points. Let's duplicate spawn point 1. I'll have one over here. Then I'll duplicate it again. I'll basically put them in the four corners of my little map here. Okay, so let's do, so we got spawn point. I'm going to rename this just to make it a little bit easier. This is actually going to be spawn point 2. It's not going to let me do it because here we go. 2. Am I still playing the game? No. Or, come on. Huh? It doesn't. There we go. Okay, so got spawn point 1, 2, 3, and 4. Okay. Now in my script, here's what we're gonna have to do. So we got spawn point 1. 2, 3, 4. Okay. Because then if I wanted to have multiples of these, I need to call the command a couple different times, right? Yeah, it's freaking out right now because it's like, I don't know what all this is. Spawn point 1. Oops. That's where I messed up. Yep, there we go. They all appear over here, and now I'm just loading them in. That one goes there, so on and so forth. Like so. Do I have 2 spawn point 1s? Well, we can deal with it. Yep. I know. It's the end of the week. Let's see which one. I missed 2. Got it. Oops. I'll get it. I'll get there eventually. Bloop. Now, if you look carefully at what we have going on here, I mean, it's working, right? We're getting multiple things spawn at the exact same time. Rock and roll, man. I like it very much. However, if we go back to our code, man, we're doing a lot inside of start, inside the start function. Is there a way that we can simplify this inside of the start function? That's a lot to ask the start function to do. Here's what we're going to do. Let's cut and paste this into its own function. And we'll say function, we'll call it create capsules. Boop, like that. Okay. And then now, inside the start function, all we have to do is do create capsules. We'll call that function that we just wrote. Make sure I spelled it correctly. Copy. Paste. Yep. Save it. And now we'll get the exact same thing. They all go in the same direction, which is kind of cool. Anytime that we can distill and get a whole bunch of code down into one line and one function is pretty handy, because now whenever we want to instantiate all the capsules, I don't have to copy and paste that big block of code. I can just call the custom function, right? Whenever I want to copy those or create those 4 things, just create capsules, right? You'll see this often in more complex scenarios where it's like generate, spawn enemies, close doors, create, create coins or something like that, right? Global functions that do a lot of things at once, right? Pretty neato, huh? Yep. Yeah, it really does, help a lot. Okay. All right. One other thing, and let me just start the game here so you guys can see this. Check it out. I think it's important to note that look at how all of these instantiated game objects show up inside of the hierarchy. Yeah, they show up as clones. So we know pretty quickly, just by reading the contents of our hierarchy, the role and how these game objects were created, right? They show up as clones. Now, these are first-party game objects. They're just being generated a little bit differently. We can still go in and destroy them and kill them. We can interact with them any way that we normally would, okay? So let's do this. Let's go in and start getting rid of some of our capsules. We'll do a simple little game here. Now, just want to make sure, look at my level from the top. Make sure I can walk over to all my spawn points. Yep. Bloop, bloop. Excellent. Okay, great. Aha, wonderful. All right. So now, let's go in and make some big changes here. So I want to be able to go in and destroy these things, okay? How are we going to do this? We've done this a couple times before. Let's figure it out. Let's figure out the logic behind it. How are we going to generate the destruction of each one of these capsules? Big picture idea here. Let's prototype this in English, and then we'll prototype it in code, right? Big picture idea is that when I go over to the game object and touch the game object, it dies, right? So with that said, where are we going to begin? What type of code structure are we going to need to develop? Don't necessarily have to do a Boolean. And specifically, we need to detect some sort of collision, right? Yeah, we're going to need to detect some sort of collision. Now, where is this collision going to happen? Probably the best place for this collision to happen is on the capsule itself. I think maybe a cool idea and maybe a good practice to get into is to write or to extend the script that's controlling the rotation of our capsules to detect some collision. So, function on collision, right? If something hits me, destroy me, right? Let's see what that looks like. Let's go back over to our code and monitor develop and start working on that. Here's the red capsule controller script. And let's start prototyping what all that's going to look like. So we'll do function on collision. Let's just get the structure here done. There we go. What's next? So what we could do, I guess, is we can just do destroy. So whenever something collides with this thing, it gets destroyed. Let's see what happens. Oops. I want to make sure I got this right. Did I misspell destroy? Why does that not work? Yeah, I forgot to put game object in this. Yep. Duh. Destroy. Come on, fingers. I can do it. It's the end of the week. My mind's turned into a pile of goo. There we go. The compiler error goes away. I start the game. All my capsules are instantiated. If I go over and touch one, Well, we're not needing the trigger at this moment because we're just trying to detect collision. Okay. Ooh, that was close. Almost fell off. They do look like giant Tic Tacs, right? Now, really, I think what's going on here, in order for us to detect collision, let's see. Let's go into the collider. We don't need is trigger on. Let's just see if is trigger fixes it. Now, notice that I'm making the changes here to the actual prefab itself. And if I save my scene and save my project, anytime I make it on the prefab, and any instantiated clone will also adopt that change. Another great, powerful feature. Yeah, I didn't think that was going to work. All right. Oops. Go back into monitor develop. Let's consult my notes here. Yeah, you could do that. Here we go. Make sure I got everything correct. So we're rotating it, and then did I spell it right? Oh, probably should do on collision enter. No, we don't have to do that. I was right. But we could do on collision enter. Let's just do that. On collision enter. Don't need two functions in there. The other thing in here that we probably need. There we go. That worked. Boop. So whenever I touch them, they get destroyed. And watch what happens over inside of my hierarchy. I can't zoom in on it, so you have to look on your own. But look at my hierarchy. What's physically happening to every single one of those 4 instantiated capsules? Yeah, they're going away, right? So we're both generating and now destroying, okay? Which is pretty cool. We give life, and then we also bring death, right? It's pretty fun. Pretty cool, huh? Now this then becomes a major structure for us to continue to toy with, right? Because think about it. Maybe in a more complex environment, you have a lot of game objects that are moving, right? You have platforms, you have enemies, you have other players cruising around the scene. How can we filter and make sure that only me, the player, is now being the driver of this collision and destruction system? Yeah, let's tag the player, right? Because if there's an enemy AI cruising around, let's pretend these capsules are like cool little coins. If there's enemy AI cruising around, we don't want those other enemy AIs to bump into my coin and to destroy it, right? The only thing that's going to destroy the coin is going to be me. So let's just do that real fast. Let's return to monodevelop and continue to extend our script a little bit. And this is where it gets fun, because now here's what I'm going to do. I'm going to create a variable called hit. And it's going to be all the collider information. And let's create a small conditional state. We'll say if. I like creating the structure here before I go any further. This is just me because I'm a control freak. Okay, if what? So anyone remember? How do we tag a player in there? Huh? Say that again? Well, whatever. Huh? So if hit dot game object dot tag, right, is equal to player. Okay. If hit, so whatever is captured inside this variable, if hit dot game object dot dot tag is equal to player, then destroy the game object, right? Save that, return to Unity. Before I go any further, I have to tag my first-person controller prefab as player. Looks like I made a small mistake here. Can't remember if game object is capitalized. Oops. Okay, no, I had it right. Game object, yep. So what is Unity's big beef? It says this message parameter has to be type collision. Oh, oops, not collider. Collision. Here we go. Goes away. Awesome. Let's play it now. Okay, so now the only thing on the face of the planet that can destroy the capsules is me. Bum, bum, bum. Let's prove this beyond any reasonable doubt. I'll stop the game and then once again return to my game controller. Let's just change the tag. Let's change the tag to game controller just for giggles. Okay? What would you expect is going to happen now? Not a single thing, right? Because we've changed the tag. Bloop. Yep. I can jump into it now, and it's not going to do a single thing. Cool, huh? Pretty neat. And when I stop the game, everything gets destroyed from my asset or from my level as well. FYI, I forgot to mention this when we were talking about this instantiation thing. It also makes working in your editor very, very light, okay? Because now, the only time that these things are placed in the level is when we play the game, right? I've seen people do this on entire levels before. They'll play the game and the entire, certain prop pieces are then instantiated on the level itself just to make working in the editor very light and easy and smooth and fluid. Cool, huh? All right. Questions on this idea? All right. I tell you what. I've been going for about an hour. Let's just take a small little break, and we'll talk about bullets, which is going to piggyback on this entire idea. Okay, let's get back to work. Break time over. So where we left before we went on our break was here. Let's check it out. Let's go ahead and start the game. Bloop, bloop. Everything instantiates. Blup, blup, blup. Oh, that's right. I changed my player tag. Let me just go and swap that back to player. Fire it off again. Da-da-da-da. I go and jump at my capsules. They destroyed. You know, one of the things that I want to encourage you guys to remember and continue to use are all the code snippets that I've been placing on, inside of our learning resources module inside of Canvas, because this is in every sense the underpinning of an entire collection system. Coins, destroyable objects that will give our player a point. Right? We've already talked about how to kind of wire all that stuff together. Kind of the cool thing, and inherently the big challenge in game design, and just programming as a whole, is taking all of these component pieces, all of these smaller little chunks of programming code, and figuring out a way to physically weld them together to create some sort of dynamic or function inside the game itself. That's where it gets fun. Okay, so let's add a new layer into this. Okay, what I want to do now is start playing around with physics. Okay, because the physics component of this is pretty cool. As I mentioned before, the goal for this is to fire off like some weapons, okay? To fire off a gun. Maybe the gun will go out, hit our capsule, and destroy our capsule. That's cool. I like that, okay? Let's do it in small little chunks first. So first, it's all about low-hanging fruit. The first thing that we need to get working is the actual instantiation of a bullet and being able to, to fire forward, okay? Let's go do that real fast. All right, so before we can do that intelligently, let's go in and physically create a game prefab for the actual bullet itself. I think what I'm going to use is just a small little cube, because I think it'd be cool to shoot like a little cube, see it like fly out in the air and like destroy something. That'd be pretty rad, right? All right, so let's add in game object. Let's add in a simple three-dimensional cube into our scene. Because I'm a mega nerd and a control freak, I'm going to reset its transforms just so it's right there at the origin. And as I mentioned before, I want this thing to be green. So let's create custom material. Oh, let's make sure I don't have a green one already. Nope, just red. Let's add a green material. Oh, I don't know why I want my bullet to be green. I just do. So just deal with it. Lovely shade of green. So it's nice and bright, something that we can easily see. And that's really where I'm going with all this. Just something very, very, very easy to see. We're going to make it pretty small, too, because, bullets are pretty small. Okay. Let's rename this game object. Call this bullet prefab. I'll drag it down into my properties tab so I can save it. And I can call upon it wherever I want. There it is right there. I don't need the original anymore, so let's get rid of it. Let's delete it. All right. Let's get this party started. So here's what we're going to do. We need to go in and create a couple lines of code here that's going to instantiate the bullet, add a rigid body to it, and then push that object out some distance. Okay? We're going to use the rigid body dynamic system to kind of push some things around here. Physics, basically. Okay? We're going to add a force to a bullet, which is going to propel it forward. A lot of good, all bullets, all projectiles in games have some sort of arc of travel that they go across, right? Think of a rocket launcher or a grenade. If the opponent is relatively close, it looks like it's going to go in a straight line. But if the target is way off in the distance, it actually arcs in, because after a certain distance, gravity is going to take over and begin to pull that object back down to Mother Earth. So physics are a great way to play with bullets. It's not the only way. There's another process called ray casting, which will allow us to fire off a ray. That's cool too. We'll talk about ray casting as we get closer to the end of the semester. But let's go in and start figuring out what we need to do to get our little bullet firing off from our player. So as one might imagine, let's take this step back here for a second. Where are we going to place this script? What's going to be the controller of the instantiation of the bullet and its kind of relative push out into our three-dimensional scene? What makes sense? If you're playing Call of Duty at home, what drives the creation of... Yep, absolutely. So we definitely want to tie into your mouse clicks, which is tied to which game controller specifically? The game controller, right? The first-person controller prefab, right? So this whole chunk is going to go on the first-person controller, right? Because keep in mind, there's some important ideas in here that we need to capture, right? We want to be able to capture the player's current location and use the player's current location to determine the instantiation of our object, okay? Right? We also want to use the player's current rotation to determine the rotation values that are going to be implied and infused upon our instantiated object. So all this is going to go on the player, right? And the game controller is one of the few things inside of our system that's going to be listening for some very important input access, and we'll see that here in a second. All right, so let's go over to our first-person controller prefab. Now, if we look at the way this prefab has been constructed, there's already a couple things in here. There's already a script. So I want to make sure that we're not duplicating this name at all. Let's add a new script in here. New script. What are we going to call this? We'll just call this, I don't know, Pat's character controller. Awesome. Let's double click on it, open it up in good old mono develop, and start the construction of our little script. So the script has to do a couple different things. What are they? This is like our weapons script. What's it going to need to do? I like that. Update all the time. Yeah, absolutely. We should always be listening for some sort of input. I like that. With that in mind, we can already begin to understand pretty quickly that a lot of this stuff is going to be placed inside of the update function. So we need to detect some sort of input. What input is that going to be? I like it. Mouse down, right? Okay. Mouse down. And what mouse button? Yeah, left mouse button. We'll just do left mouse button for today. Okay. What else are we going to need to do? So we'll listen for an input. What's going to happen when we hit the mouse button? Not the FPS controller. The cube, the bullet, right? So we're going to need... Bingo. Yeah, absolutely. Yeah, that's right. Yes, we'll have to instantiate, and the cube will be instantiated at the location of the game controller, right? Or the first-person controller prefab. So we're going to have to be listening for an input. We're going to instantiate, and then we also need to push. We need to start playing around with physics a little bit, and it's a tremendous amount of fun. Okay? Let's just do that real fast. Let's start plugging all this stuff together. First, and you know my strategy here, let's prototype as we go. Okay? Let's prototype and test to see if we're actually capturing some sort of click, all right? Now, how we do this is very similar to how we did it with key presses, right? I can key press the cow comes home, right? We have that code snippet and understanding from a previous lecture. But let's go in and look at how we can start working with mouse inputs, and it's really, really easy, okay? Once again, we'll write a conditional statement if something happens. If, much like we did key presses, right? And let's just do a debug. Oops. Debug.log. I like it. And then in quotes, you have has. Gosh, I cannot type today. Clicked the button. Jeez, the beaten, right? That happens when you've been lecturing for like 5 days straight. On Fridays, things just kind of blur together. I lose all capacity to type on Friday afternoons. Okay, so that's what we're going to, so this is the result of our conditional statement, right? We're going to write to the debug log, you have clicked the button, okay? Or let's get a little bit more specific. You have clicked the mouse button, okay? So how do we write that conditional statement? What are we going to ask again? Well, it's very, very similar to what we did with the key presses, but it's not going to be input.getKeyPress, right? It's going to be input.getKey down. There we go. Or if you like, some people like doing it on key up. By the way, it works. Get key down. or excuse me, not key, because it's not key presses, it's buttons. Yeah, get button down. So when we click on the mouse, when we go button down, it's going to register. Okay. Now we need to tell it specifically, well, which button. Okay. Which mouse button are we going to use? And the cool thing about working inside of Unity is that they've built in some shortcuts for us. Okay. We don't necessarily have to go in and define specifically which mouse input to do. Okay. The guys and gals down at the Unity development team have done some of this for us. Okay. And we can check it out by going into the Edit pull-down menu under Project Settings, and then Input. These are all the shortcuts. These are all the prefabs, if you will, that the Unity development team has created for us. They're called axes. Here we go. So here's the list. These are physically the words that we can call upon in code, and the Unity engine will do something for us. Okay? If we start to explore this, we can see that we have Fire 1, which is mouse 0, which is cool. Fire 2, which is mouse 1. Okay. Horizontal and vertical, A and D, left and right keys on your keyboards. So there's some shortcuts in here that we can use to very quickly kind of put all this stuff together. Yeah. Cool, huh? So we'll do Fire 1, because that's the left mouse button. So we'll put in our quotes here, Fire 1. All right. Let's save our script, return to Unity, and see if our conditional statement works. Because if it works, click the mouse button, it registers the content down here in the console. Woo! It works. Okay? That part of our script is confirmed. We've appropriately tested and proven that we're registering the input that we're after. Okay. Now comes the fun part. Now what we need to do is start instantiating our bullet. Okay. Now so the moment we click, we need to instantiate. Okay. So every time we click, we're going to instantiate one of our bullets. Okay. Let's get rid of the debug.log and start instantiating. Instantiate. Now remember, okay, how do we instantiate? What are the 3 things that we need to figure out in order to instantiate? What we're going to instantiate? In our case, what are we instantiating? The bullet prefab. Okay? What comes next? Where we instantiate. And lastly, it's rotation. Okay? Let's do this. Open and close parentheses. So this is going to be bullet prefab. Now, at the moment, we don't want to hard code in the actual name of the game object that shows up inside of our project settings. Let's do exactly what we did previously with the little spinning capsules and write our code generically so that we can load in any game object in the inspector. That makes it very fluid and easy. Because what we always want to be giving our game designers an opportunity to change what we're instantiating. Maybe at some moments we're instantiating the bubble or the bullet. Maybe in other moments we're instantiating a grenade or an ammo box or something. Writing our code generically allows us to, infuses a certain level of flexibility inside of our system. So let's do it real fast. Let's go in, much like we did with the capsules, let's create a public variable. We'll call this bullet. That's not how you spell bullet. Nor is that. And like we did with our capsules, transform. There we go. Bloop, bloop. Wonderful. Okay. So now, down here in the instantiation commands, we'll instantiate our variable bullet. And let's do this. We're going to do transform.position and then transform.rotation. Okay? Now, when I write transform.rotation and transform.position, it's going to adopt the game object that this script is currently chilling on. It's going to adopt its transform, right? So the game object that this script is going to be associated with is our game controller, right? Our first-person controller prefab. So we're always going to instantiate our little cube here wherever our game object is, wherever our gamer is, which is what we want, okay? Let's save it. Go back over into Unity and prototype. Okay? See if it works. Let's do some play testing. Now, if we return to our first-person controller prefab, yes, we've written our code correctly, and the bullet variable has been exposed inside the editor. So now we can go in and start to populate that with our actual prefab itself, which is right there. Awesome sauce. Let's take a look at it. Let's play the game. This will be entertaining. Actually, I want to do this. I want to zoom out a little bit in my inspector because I always want to be able to see. I really don't care so much about the game view at the moment. Okay, everything's working. I can cruise around. Now, what do you think is going to happen when I click? Bloop, 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 bloop. It's like I'm laying little eggs. That's trippy, right? Now, whenever I click here, you can see that I'm creating a small little trail of eggs to cruise around. They also have rigid bodies, which is a problem because I can't walk through them. Also, what are some of the other problems that this little playtest session has kind of produced for us? They don't have physics, so they're not actually going anywhere. We're instantiating, yeah, rock and roll, but they're not being pushed out. We'll come to that in a minute. Let's get the low-hanging fruit out of the way. Absolutely. So we have to get rid of them at some point, right? Because look, they're still chilling. The game is still running right now, and they haven't been destroyed from my hierarchy. That is a problem, right? When should they get destroyed? When they hit something, right? Or what if we miss? So after a period of time. So both of those things we can do pretty quickly, right? We can write a conditional statement. We can say, if you hit something, destroy it. If else, destroy after a period of time. So we have to have a new script now. A new script that's going to control my little bullets to destroy them appropriately in the scene. And then what else do we need to do on the bullets? Before we get to that, from what we've just play tested here, because I'm a big believer that whenever you play test, fix the problems that are immediately presented to you in the play test session. That way you don't get confused. We're going to get to that in a minute. The other problem that we're running into here is that they got rigid bodies associated with them, right? And I'm physically not able to go through them. That's a problem. That's a problem, because if you look downstairs, poof, they're physically stopping me from cruising around. So let's do the low-hanging fruit first. Playtest, fix. Playtest, fix. That way, when you're fixing things and changing your code, you understand pretty immediately what you're fixing and how you've done it. Okay? Try to keep it simple. I'm a simple-minded guy. All right, here we go. Let's do it. Let's start fixing some things. Let's go back down into my bullet prefab. Now, luckily for us, if we go into the box collider on the bullet prefab, if you just turn on is trigger, then we're good, right? Now I can play the game. I can pop out a lot of these bullets, okay, and I can walk through every single one of them, which is what I'm after. That problem solved. Second problem we got to solve is getting rid of them. Okay, destroying them after a period of time or when they hit something. Okay, so let's go ahead and start writing that little structure here. We'll need a new script that's going to go on the bullet. There we go. Now I'm doing this naturally on the actual bullet prefab itself. And so what are we going to do here? When should we be destroying these bullets? In the update. Let's do the time destruction first, and then once we have everything else kind of in tow and working, we'll go back in and make the conditional destruction when it actually hits one of the capsules, the red spinning capsules, okay? So under function update, now it should be under update or should be on function start? And actually it's not. Let's do this, because we could do it under function update. Let's see what we get. So let's just destroy. What are we going to destroy? The game object that this script is attached to. And then after how long? 3 seconds? Yeah, that's good. Save it. Semicolon at the end. Save it and return back into Unity. Any compiler errors? No compiler errors. Let's see if it works. Go in. We'll lay a couple green eggs. And there they all. They get destroyed. Huh? I can keep making them. Keep making them till the cows come home. It's a pretty little trail of eggs that I'm leaving here. Okay. Those problems solved, which is what I want, right? And if you notice in my hierarchy, clearly every time that I click, okay, I'm getting some new game objects created in the hierarchy. Now, oops, I fell off the edge of the map. There we go, and then every 3 seconds they get destroyed. I like it. Okay, this is good game design. We're creating and destroying. We're creating and we're destroying. We're not leaving them in the scene and just turning off their visibility. What would happen to the performance of our game if we left them in the scene and just turned their visibility off? Oh, it just bogged down, right? Your performance would just plummet pretty quickly. All right, so let's continue on, as they say. All right. So now let's return to Mono Develop and go back to Pat's character controller, the script that's actually in charge of creating the bullet. And let's do some fun things here. Okay? What we're going to do is that we're going to add a rigid body to our little bullet. Because right now, if you look at the prefab on this, there's not a rigid body here. Okay? Actually, let's see. In the script notes that I have, a rigid body is currently on there. So we'll just add the force to it. So let's go back and do this. This will be fun. I'm going to go back into my bullet prefab, and I'm going to go in and add a rigid body. Now, whenever we add a rigid body to a game object, it now becomes influenced by the game engine's understanding of real-world physics, okay? And you can see some things in here. We're going to increase its weight, its understanding of like friction in the air, which is going to be its drag. There's a lot of control that we can place on inside of this rigid body game component. With that in mind, let's see what happens to our world when now check it out, they start falling, which is pretty fun. Okay, that's all thanks to that rigid body. They're not colliding with the plane, and it may have everything to do with the plane itself. Let's see, if we do is convex on the plane. No, that doesn't change anything.
No, the collider's big, so they spawn inside of it and they fall below.
That's exactly what's happening. Yeah. Well, when is convex is, let's do this.
But it's so big that they spawn inside of it and then go down and hit the bottom.
Let's see. But when it's off, it should be, it's a mesh collider, right? So when it's off, it should be bouncing on the surface. We'll figure that out. That's not impossible. It may have everything to do with the mesh collider and the plane game object itself, the bullet itself. So the bullet has a box collider. Now, is trigger is on. That's why it's not bouncing. Yeah, that's why. Now they'll be left. Yeah. That's entertaining. Okay. So we can make that work. One thing that we can do, actually this is going to tie in quite nicely to the next component here, because what we want to do is basically activate, or in this case we want to deactivate the bullet prefabs trigger channel when it strikes something else, right? Yeah, we'll see if we can get that fixed at the end. But for right now, we'll leave the is trigger off on our bullet prefab just to keep things a little bit easier to understand. All right, so things are working well. Our little bullet prefab has a rigid body. Now we want to go into our character controller and start doing a little bit of a push on this, okay? So here's what we need to do, and I may have done this incorrectly. Let's continue to go in and add a little bit, okay? So we're going to access our bullet variable, okay? So remember, our bullet variable is really a game object, okay? So we're grabbing the game object, and then specifically, we want to talk to the rigid body game component on that game object. Rigid body. Then we're going to do add force. Add force. And this is where we need to get a little bit more specific, okay? Because the rigid body add force command requires two different little chunks to be passed into it. Clearly a direction. Which way are we going to push this thing? And then how much, right? How much of a force are we going to add into it? Well, luckily for let's just do this. Let's do a search for rigid body add force inside the Unity documentation. Here we go. And let's see if we can get. Yep. So here are the parameters. Size of the force. The mode is type. Let's see if there's any really great code examples here. Yep. Transform.forward. Okay, that's the direction we're going to be pushing this object along. And the thrust is how much. Okay. Let's see. Sometimes if you start reading the documentation, you can get a really good understanding of what's required. Yeah, here we go. You can actually see it right here. Here's the function add force. This is the direction stuff. Okay. Now we also can do a mode as well. The mode is, it looks like it's just taking a number. Okay. All right. So the direction is going to be transform.forward. Forward. Okay. And then we're going to multiply that by a value. Let's just do 2,000. Save the game, go back over into Unity. Oh no, did it just crash on me? Oh, that's right, they changed how we do this now. Okay. Let's go back into Unity documentation. That could be it. Yeah, because I forgot. We did this, but we've done this before a couple times this semester. I need to update my notes for the lecture. Because now we can't just access it. We got to get the component, save it as a variable, and then load it in there. So let's do this. Oops. The way we're doing this, there's a. Let's try this. Let's try this. I want to make a private variable called Pat's bullet, and we're going to set that to basically all of this. Okay. So whenever I call Pat's bullet, we're actually creating the bullet instead of our scene itself. Now, copy, paste. Okay. Let's see if that works. Save it, go back over into Unity. All my compiler errors go away. They do not. Yeah, okay. So they're going to have me go through this entire mumbo jumbo to get this to work. Go back in time a couple steps here. Okay, so what is it, under function start or function awake? I can't remember now. Function start. And we'll use the example that the code documentation does just to make it easy. Equals get component, and then we tell it what. Rigid body. Well, I'm concerned now. Here's the problem that we now have with this, because my structure is entirely wrong now. Because I'm getting the rigid body of the game controller, not of the actual bullet itself. So perhaps what we should do to sidestep this entire problem is that we should put this chunk of code on my bullet rather than my game controller. Yeah. Let's see, how would that work? Yeah, I forgot that they're asking us to do it this way now. How dare they make changes? Let's see. So I want to get this variables. I want to get that variables rigid body. Let's try this. I'm curious if this is going to work. We'll do bullet.getComponent.rigidBody. Let's save that. Let's go back and see if that works. Now, did I misspell something? It's very likely I misspelled something. Aha! There's my problem. I capitalized body. That needs to be lowercase. Let's see if that works. I know I did for RB because I didn't declare it as a variable. RB, how'd they do it in their code? Oh, interesting. Let's try that. I'm curious how that's going to work. Yeah, it's not liking that at all. Get rid of that. Wait for it. Wait for it. Get component, rigid body. Oh my gosh, the train is derailed here. Am I misspelling something? Rigid body. Well, this is a complete failure, isn't it? I know. Everyone has bad days. I'm not sweating it. Yeah, it's not liking this. I misspell something? Here, let's do this. And instead of trying to hack it to make it work on the character controller, why don't we just do this on? Yeah, we'll take all of this stuff, all this force stuff, and we'll put it on the bullet prefab, the script that's controlling the bullet prefab. So whenever, because what we want here is when the bullet is instantiated, it's immediately pushed, right? Let's see if we can get that to work, because that may be the way to go. All right, we're going to get this right here. So on function start, we're going to do the exact same thing. We'll get the rigid body. Okay. RB equals rigid body. We'll save that. Cat. And then this is where, let's get rid of this. Get rid of that. All right, let's see if this works. I have no idea if this is going to work. Hey, look at that. Yeah, it worked. Kinda. It kinda worked. Yeah, it's working. I mean, it is going. It's just not going very far. And you know what's actually happening here? This is entertaining. What's actually happening here? It's not. It's coming out of the middle of the game controller, and it's hitting the inside of the capsule collider and then bouncing back. Because remember, our first-person controller prefab has a capsule collider around it, right? So it's hitting the collider and then bouncing back inside. So what do we need to do here? This is funny. Well, we need to, because if you look at the way the scripts are created here in this moment, okay? So FYI, some of you guys were playtesting your levels while I was troubleshooting my problem. The issue that we ran into is that they've changed the process in which we call and access game components on an existing game object, right? So what we did is that on the character controller is just responsible for generating and instantiating the bullet, right? The script that's controlling the bullet is actually pushing it out into the scene itself, okay? So we've kind of separated it. Previously, they were all on the game controller script, so we've separated it out. It is working, but at the moment, where's it instantiating it? Yeah, from the game controller's position, right? So maybe what we should do is change our script ever so slightly and create a bullet spawn point like we did with our capsules, okay? That will generate and determine where our little guy is going to be fired from. Now this is where it gets really entertaining, because if we look at our rigid body controller here, all right, let's have some fun here with this, okay? I'm going to create the dorkiest little weapon. Just give me the Academy Award right now. It is a stick. Can they? Oh, I was not aware of that. There it is. There's my little stick. Let's make it a little bigger. We'll give it a unique color as well. Yeah. Now I'll make it look like our player's kind of holding something. Pew, 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 pew. Yes, sound effects are required. There we go. Okay, there's my gun. All right, awesome, right? Let's just call this gun model. Huh? It's a blow dart, right? Yeah. Okay. And what I'm going to do, in order to get this, I need my gun model to move with my rigid body first-person controller. So I'm going to parent it onto the actual object itself. Now let's prototype that. Yep. Should be kind of walking. Now it's not looking, I need to parent it to the main camera, because the main camera is the one that's responsible. There we go. There it goes. You can see what's happening here. Awesome. I'm pooping out little green cubes. Okay. Okay. But they're not being spawned from the actual controller, from the actual tip of the gun itself. Okay. Now the tip of the gun is going to need to be defined by an empty game object. So let's do that. It's the only way to really get laser focused as to easily defining a location, right? Okay, so that little location right where my locator is, that's where I want all of my bullets to be generated from. Let's call this bullet spawn. Okay, and I'm going to parent that to my gun model. That way, whenever I move, they all move in tandem with each other, right? Roger, you feeling me? Okay. Now we go back to our script, okay, and we change what's happening here, right, or where it's being spawned from. So let's do this. Let's do a new variable. We'll call this bullet spawn point. We'll data type it to a transform. So we're looking for location information. I'm going to copy the name of the variable and put it down here. Now, when we do this, we have to change, since it's someone else's position, we have to capitalize the P, and it's not rotation, it's rotate. Okay? It's transform.lowercase position when it's my position. It's transform.uppercase position when it's someone else's position channels. And for rotate, it's not my rotation, it's someone else's rotate. Okay? Does that make sense? Okay. Because now we're accessing a very specific channel on a separate game object. Let's save our scene, our script, go back into our Unity editor. Now we're getting some errors. What would the error say? Did you mean position? Maybe it is a lowercase p. Maybe it is a lowercase r too. Did you mean rotate? Yeah, no likey that. Bullet, is it no likey because it doesn't know? Bullet spawn. No, that should have worked. Hold on a sec. Let me check something out real fast on all my code snippets. Yeah, lowercase it. Maybe I had it completely wrong just then. Let's try rotation. Yeah, I had it completely wrong. Ignore everything that I say today. Oops, I hadn't assigned the bullet spawn point variable. Now we're good to go. Let's clear my console. Let's see if it works. Keep your fingers crossed. Yes, it is working. Let's play some Minecraft now. What's going on here? They're dropping immediately. Are they doing exactly what they should be doing? No, they're not doing at all what they should be doing, right? Why aren't they going the opposite direction? Interesting question, right? They should be going the opposite direction from where they're going. They actually are doing what they should be doing, but what's it appear to be doing? Let's start the game real fast. I've selected my bullet spawn so you guys can see it. Okay. Now, in transform dot, or if you go back over here into our script, the bullet controller, check it out. We're doing transform dot forward. Okay. How do you define forwards in our three-dimensional scene? Positive Z. Look very carefully at my inspector. Which direction, just kind of spatially inside of the editor, is my bullet spawn point facing? Back into the gun, right? You can see the indicator line here that represents transform.forward. What do I need to do to my locator? Maybe spin it around 180 degrees? Because right now, the bullets, they're spawning, they're being shot forward into the gun, right? So they're falling immediately. If we spin the locator around 180 degrees, We'll see what we get here. I'm going to do this mathematically. Okay. Now let's see what we get. Same thing. So that wasn't it. Maybe I'm not adding enough of a force in here. Transform.forward times 2,000. Let's put this at 10. 1, 2, 3. Save it. Now it works. So 2,000 was not enough. 10,000, a little too much. Let's go in and start dialing this. Now, taking everything we talked about today, how can I make this a value that I can interactively change in the inspector? I don't want to always have to go back to code. Variable. Yeah, you got it. Instead of putting a number in there, let's put force. Okay. Oops. And then at the beginning of my script, I'll define the force variable as an integer. Okay. You could also do float. Real pop quiz? What's the difference between an integer value and a float value? You got it. Integers are whole numbers, right? So if you really wanted the granularity of that decimal point in there, a float value would work. I think for what we're doing in here, that's probably pretty good. Let's save it, go back over here to Unity. I'm going to grab my bullet. Let's see. Yeah, now, well, right now, and check it out, this may be not the best way to work because we're capturing this information on, or we've placed this information on the script that's responsible for the bullet prefab. The bullet prefab is actually not a member of our scene until it's instantiated, right? So what if we do this? What if we make this, oops. What if we go in, there's a lot of different ways you can do this. If I put this to 10,000, okay, let's see what happens. I'm not sure. Yep, it's still going to work. Okay. However, the problem is that whenever I need to make a change, I gotta go find that bullet prefab in my project, which isn't good design, right? It'd be better if, I don't know, like here, in Pat's character controller, we have like weapon speed or bullet speed or something. Okay. Let's change the way we're writing this a little bit to make it a little bit easier. Okay. So instead of putting the variable in the bullet controller script, let's do this. I'm going to just change the name of the variable to bullet speed. Okay. And let's put this on Pat's character controller script. Pat's character controller dot bullet speed. Okay. Over here, static variable, right? Remember this? Data type it to an integer. We'll save everything, go back into Unity, see if it works. And it will certainly save everything. I probably didn't save all my scripts. Make sure I'm spelling everything correctly. No, still not showing up. Why not? Okay. That's interesting. And now it's working. kind of. But it's not allowing me to change it. I got to figure out why that's not working here. Okay. So life is good now. Cool, huh? Got to do the sound effects too. All right, so now we have an interesting challenge in front of us. It works. We're able to instantiate the bullets, fire the bullets. We're controlling the speed of the bullets through our code. Now we want them to destroy our little capsules. How are we going to do that? Tag the bullets with what? Bullets. Let's create a custom tag. It's a great way of working. Let's start off with doing that, right? Bullet. Okay. Now I need to return to the prefab, right? The bullet prefab itself. Make sure that the bullet prefab is getting that custom tag. Okay. If we return to monodevelop, where should we place this little chunk of code? I think we did on the red capsule controller. Yep. So if the player hits the capsule, it'll get destroyed. However, we probably should do something else, right? Say again? Tag the bullet, right. So if hit.gameObject way of destroying our capsules is if we were to fire it. Touching it's not going to help. Let's save it. We'll go back over into Unity. Start our game, see what we get. Got it. Now, why does it take a couple? I don't know why it's not. That one I got it. I probably just missed it. Aha, I got them all. Aha. Awesome. Now, there's a couple other things in here that we'll want to do, and this is probably why it wasn't working a second ago. Let's see. Yeah. Okay, watch very closely. Let's see if I can get it. I got this. I got this. Did you see that the bullet ricocheted off my capsule? So what wasn't it doing? Well, it's not that there's no trigger. Yeah, if you remember on the bullet controller script, we're only destroying the bullet after 3 seconds of it being instantiated into our game space, okay? So we need to have two statements now inside of our bullet controller script. We need to do two things. Okay, let's go back into bullet controller. Because remember, every frame under update, we're saying add force, okay, which we want to be doing whenever we instantiate. But then we say, hey, destroy yourself after 3 seconds, okay? Let's do this. Maybe we add a conditional statement in here. We say if, what should the statement be? Because we need to do two things. Yeah, this could be easy, right? If we hit something, okay, if we detect some sort of collision, destroy me, okay? Otherwise, destroy me after 3 seconds, right? Say again? Well, this is the actual bullet itself. Yeah, this is the bullet. So now maybe what we should do is that we should, on every frame we'll do if. Let's just create the structure here real fast. And then we'll do else. Huh? Thank you. If else. If. Now we need to detect a collision in here. How are we going to do this? So that we only destroy this thing when it hits something. Let's consider for a second. Maybe we're not asking to do this every single frame. That'd make it easier if we put it in, if we wrap this entire idea in its own function. That could be kind of cool too. So every frame we're asking the computer to add a force to the bullet, but maybe, yeah, this may make a little bit more sense. Let's close out that function. So this is the only thing that we're doing every function on the bullet. Maybe on function, on collision, enter. Oops. Okay. On collision, enter if. Okay, if hit, not hot, hit dot game object dot tag is equal to what? Not player, but I'm just putting it in there just to, it's a placeholder. Just destroy. Okay. Else destroy after 3 seconds. So what are we going to calculate here? So if what we hit is just target, maybe, let's do that. We'll create another tag. We'll call it target. Or it could be enemy. I think enemy is actually one of the defaults. Enemy tags. And that's, there we go. Did I spell enemy wrong? I had it right the first time. I'll fix it. Okay. And enemy. Go back in. Now we need to make sure that all of our capsules. Let's find our capsules. Target. This is an enemy. Let's see if it works now. Cool. And it's destroying. That's cool. You see it bounce in there? Yeah, the bullet was being destroyed the moment it hit it too, which is cool, which is a mission accomplished. Yeah. It works. How about that, huh? Fun with physics. Yeah. I like it. I like it. Good times, huh? It's amazing how much goes into the creation of a weapon system. It really does. Okay? But keep in mind the core tenets behind this. We're instantiating a bullet, a game object. We're pushing it with its rigid body. And then we're destroying it based off of what it's hitting. Okay? In a couple seconds here, I'll put all the code on the Canvas site so you guys have access to it so you can use it inside of your games going forward. There are other variations of this, by the way. This is just a very, very rudimentary system. It's very simple, but it works. It's pretty generic, and it's designed to be generic, so we can swap game prefabs pretty quickly. Think of it from the design perspective or from a development environment. The way I've written my code, we can update the bullet model at any time, right? Just by swapping out the prefab. I can update basically any of the prefabs at any time within the development process and not have to recode a single line of code, which is pretty rad, right? I think it's pretty cool. Makes it easier to go through the system. It's not perfect. There's some bugs in my game. Like, I'm not sure why. I got to bang on it for a second. Why I shoot this thing. And upon the fourth one, there's a pattern here. I may be missing it. Yeah, I don't think I'm missing it. That could be possible. Maybe it was just missing it. Or, you know what we may have to do? We may have to just go in and make the rigid body for a capsule. Let's make it a little bit bigger. That one bounced off it for some reason. That one's working pretty good. Mission accomplished. That seemed to fix one problem and may have not solved another. Yep. All right. Questions, questions, questions. Yes, sir. I'm sorry, I couldn't quite hear you. Instantiating liquid. Well, we have to define what liquid is. Water. So now you're talking about a particle effect, right? Yeah. Yeah. Water would be some sort of particle generator inside of Unity. I don't actually have a whole lot of experience with the particle generators inside of Unity. So you may want to play around with that and look at some of the documentation online to continue that conversation. The same ideas would be in tow, though. The exact same ideas. All right, so we got about, what? About 45 minutes left in class. Let's continue moving forward on our final project in here, okay? So hopefully everyone should have some sort of white box prototype for their game, yeah? No? Yeah, who has a prototype of their final project? Exactly one person. Rock and roll. David, you can go home. You're done for the day. My gift to you, no, you don't have to go home. Although if you'd like to, that's fine. So here's what I want everyone to do. I see a lot of people working in Modo right now, which is awesome. Yay for that, right? But you really shouldn't be working in Modo until you have a prototype in hand, right? You don't know what you're going to have to build until you actually prototype and play test it. Because heaven forbid you make a change that is going to force you to return to Modo and make a change to a major art asset. Okay? Let's get a prototype done. Okay? White box it. It shouldn't take too long to throw this stuff together. You won't really have a good solid understanding of the playability of your level until you build it first. Okay? Let's get to work.